Welcome to section 7.2 on trigonometric integrals. The point of this section is going to be for us to evaluate integrals that are products of trig functions like sines and cosines and secants and tangents and stuff like that. Before we get into actually doing calculations, let me point out that there's lots of useful identities that you should be aware of and be ready to apply when we're doing these kind of calculations. So sine squared of x, we can rewrite it in terms of cosine of 2x. We want to get the power down. Ditto for cosine squared x, we can write in terms of cosine of 2x. Sine of 2x, we can write as a product here. Cosine of 2x, the difference of cosine squared x and sine squared x. And maybe the most important one for our purposes here is going to be this very fundamental identity, sine squared x plus cosine squared x is equal to 1. And it's worth remembering that there's also versions of this involving the other four trig functions. And the way that I like to remember those is just to derive the other two identities from this one. So first, if we divide everything by sine squared x, we end up with sine squared divided by sine squared is 1. Cosine squared divided by sine squared, that is cotangent squared. And 1 over sine squared, that is cosecant squared. And instead of divide by sine squared x, if we choose to divide by cosine squared x, we get the final of the identities. So sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1, and 1 divided by cosine squared is secant squared x. So the identities on this page we'll be using all the time throughout this section. Okay, so let's get into our first example, and it's actually going to be, I hinted at this in the last section, section 7.1. We evaluated the integral of sine cubed x in one way. Here we're going to do it in a different way in this section. So this is going to be a very typical example here. And I'm just going to get right into using a very standard trick here. And so how would you feel if I told you that this integral is one that we can do by substitution? Now that might look a little bit weird because there isn't anything, like I don't instantly see something that we can say, oh, this is u, and then there's a du floating around. But we have to use the following trick, which we saw for maybe the first time at the end of the last section, but we're going to be using this trick all the time in this section. So what we're going to do is we're going to split up sine cubed as sine squared x times sine x dx. And now for the sine squared x, we're going to use our fundamental identity here. So we know that sine squared x is 1 minus cosine squared x after rearranging. And so what we have is that we're going to replace, everywhere we see a sine squared, we're going to replace it with 1 minus cosine squared x times sine x dx. So we could rewrite this as two separate integrals, and we will. Okay, so let's take a look. We have, maybe on the surface, made our lives more complicated. We replace one integral with two integrals here. However, both of these integrals are quite easy for us to evaluate. So the integral of sine x, that is just minus cosine x. There will be a plus c. We'll see the plus c come out at the very end. And now, this is rigged. This is rigged for us to be able to apply substitution. So we're going to let u be equal to cosine x. And so now du is equal to minus sine x dx. So this right here is negative du. So when we make this replacement here, we've got, so we already did that integral. There's a minus sign and minus sign. Those are going to combine together for a plus sign, plus the integral of u squared du. So this ends up as minus cosine x. The integral of u squared is u cubed divided by 3. And then on our, let me go to a new page of notes. Our final step will just be, of course, to replace u with cosine x. Okay, so this is our final answer for the integral of sine cubed x dx. It's minus cosine x plus cosine cubed x divided by 3 plus c. So this is a pretty typical example here. This is a pretty typical example, and we'll certainly be doing this a lot more throughout the rest of the section. But let's kind of summarize. What we did was that we split off. We had an odd power sign. And anytime we have an odd power sign, we'll be able to do this. We split off something, some multiple of sine squared x. We replace it with 1 minus cosine squared x. And then we're able to either do this. We get two integrals here. This one we can do very straightforwardly. And this one we can do with substitution. And so that gives us this as our final answer. Okay, so there is one last thing that is worth remarking here, which is, to finish off this video, let's just point out here that we got a different looking answer last time. So let's point out that from before, we ended up with minus 1/3 sine squared x cosine x minus 2/3 cosine x plus c. So this looks different than what we had. However, these two actually are going to be, we can actually see that they're the same. And we can do that by, once again, let's just transform this sine squared x into 1 minus cosine squared x. So let's make that transformation. So minus 1/3 times 1 minus cosine squared x times cosine x minus 2/3 cosine x plus c. Let's split this up. So minus 1/3 cosine x, and then plus 1/3 cosine squared x times cosine x is cosine cubed x minus 2/3 cosine x plus c. And let's note that these two answers are exactly the same. So cosine cubed x over 3, cosine cubed x over 3, and minus cosine x is the same as minus 1/3 cosine x minus 2/3 cosine x. So sure enough, we can breathe a sigh of relief. Our two methods get us to the same exact answer.